Hey, welcome back to another video. So I'm going to go over some of the homework questions tonight for the FTC with Desmos, kind of show how these go. So you're going to work to follow these on your notebook paper, but I'm going to work them on here just to kind of give you an idea about how it goes. So let's take a look at question number one here. They give us the derivative. They give us this derivative right here, and it says y prime is 2 plus 1 over x squared. They give us y of 1, and they give us and we're looking for y of 3. This is a very traditional, straightforward FTC question. So to set this up, we're going to set up our integral. And our integral is going to go from 1 to 3. That's it, 1 to 3. 2 plus 1 over x squared dx. And that's going to equal, since I'm looking for a new value, this is FTC right there. So it's going to be, what's that, f of 3 minus f of 1. And we're just going to practice with Desmos then. You can do this by hand, but sometimes Desmos is really cool too. So I'm just going to type this in, int, and that's going to go from 1 to 3, and that's going to give us 2 plus 1 divided by x squared. Oops, I forgot something. Because of addition, I do need to put parentheses on these. I always forget those. Type in dx, and I get 4.667 right there, 4.667 equals. I'm looking for y of 3, so I'm going to leave that alone, f of 3, y of 3, minus f of 1, we're told is 6. So I just got to add 6 to that. And if I add 6, that's going to give me 10.667. 6, 7. All right. So pretty easy to do. I mean, that's how long these things take, man. With Desmos, takes for a little time. The Inspire is going to take you a little bit more time, but very doable as well. I have another video on that. You can go check that out on how to do these on the Inspire. God bless. So let's take a look at number 4. Oh no, cosine of x squared. So same question right here again. Calculator. We're just going to use calculator on these. It's a little bit more fun for us. We're given the derivative is cosine of x cubed. So I'm going to write that out. That goes in my integral. Cosine x cubed dx. Don't forget your dx. I'm looking for the value at 1, but I know the value at 0 is 2. So I know my domain goes from 0 to 2. So what we're looking for here is the change in the y values from 0 to 2. So as x goes from 0 to 2, right, what we're looking for is the change in the y values. We're just trying to find how much my y values are changing by. And this is just going to become f of 2 minus f of 0. So again, you can't even integrate this one if you tried. Nobody can, so we're just going to use Desmos for it. int, just type it in, 0 to 2. And I'm just going to type, whoop, hello, that's a weird looking 2 there. There we go, 0 to 2. And that's going to be, what is that? Cosine. Remember, make sure Desmos is in radian mode. Big, big, big thing. And we get this 0.855. So 0.855 minus f of 2. Oh my gosh, that was 0 to 1. That's embarrassing. All right, so we're going to fix that, Aaron. We're going to call this one, make that a 1 here. There, we're not going to talk about that one anymore, and then make that a 1. There we go. Easy to fix. Look, I made a mistake, and it was a big mistake, and it's going to cost us not much time if you notice. So if you make a mistake, it's okay. So there we go, it should be a 1. You're going to make mistakes, so just make sure you fix it. So this becomes 0.932. Mistakes are okay. We make them. I'm looking for the value at 1 minus the 2. And then if I add the 2, we get 2.932. The thing about making mistakes, when you make a mistake, fix it and move on. Be happy. All right, there we go. All right, bacteria. This is always a fun one for us. Ready right here. Number 7. All right, this is a tough one here. Okay. All right, so let f of t represent the bacteria population, which is 4 million, excuse me, at time t naught. After t hours, the population is growing at an instantaneous rate. Oh, look, there we have that word rate. For us, rate means derivative. All right, bacteria per hour. Find the total increase in the bacteria population during the first 3 hours. So it's two-part. We want to find the increase in bacteria. That's just the integral itself. And then find the population after 3 hours. That's our FTC step. So this is two-part. So the first thing we want to do is we want to find the amount of bacteria. So we're going to integrate it. That's going to go from 0 to 3. 2 to the t dt. And I cannot integrate this yet. We will by November, though. All right, so this is going to be the integral from 0 to 3, the first 3 hours. And this comes 2 caret t and dt this time. And notice we get this 10.10. We're just going to make it 10.10. Now, remember, this is million bacteria. So what we just found here is this is just the growth. This is just the increase in bacteria. So what that integral actually tells us now is for the first 3 hours, that just tells us how much the population has grown. So over those 3 hours, we added another 10.1 million bacteria to this petri dish. Good luck counting that one. Part B says, okay, we started with 4 million, so now how much do we have? Well, all you have to do is just take that 10.10 plus 4, and you get this 14.1 million bacteria. So for the second part of it, find the population after 3 hours. So we started with 4 million, and now we're left with 14.1 million. Very easy to do these. Very easy. All right, let's take a look at one more. Number 9. This is a graphing one. The same idea here. Use the fundamental theorem of calculus and the given graph. The graph of the derivative. So they're telling me that this is the graph of a derivative. And then down here they say from 1 to 4, the integral is equal to 6.2. Remember, this is just saying that's my area. That is the area underneath this graph. Find f of 1 is 3. We want to find the value at 4. Again, if I'm finding a value, this is FTC. So I'm just going to set this up. The area from 1 to 4 of our integral, f of x, f prime x dx, is just the following. F of 4 minus f of 1. They told me this was 6.2. F of 4 is what I don't know, minus f of 1, which is 3. So if I solve it, we just get 9.2. So here's what it kind of says. If you think of this in terms of physics, this says I'm starting at 3 miles. I am adding 6.2 miles. Which mile marker am I currently at? That's what this question is kind of telling us right here. All right, so take your time. Try the rest of these, okay? They're kind of fun to do. As you notice, they're not really taking terribly much time for us. So you can definitely do this. Hope you enjoyed the video.